turnkey projects for mushroom farm, agro projects from Poland, also producer of a lot of machinery and design for compost yards and mushroom farm. Farm Food, world leader in supplying mushroom supplements. McDonald Substrates, company that supply casing soil from Ireland. Grow Time, amazing gloves and other equipment for mushroom farm. Rip Style, company that supply coatings, very useful for mushroom farm and compost yard. Inema produce and supply predatory nematodes, biological special things to fight flies on your farm. Mashcomp, Dutch company with a range of equipment for mushroom farm. Amicel, world-leading spawn supplier. And Atmo Control, a company from Poland that supply a lot of very effective solutions to build a mushroom farms and compost yard. And I want to show you our nearest courses that we going to have quite soon. We did a small gap for summer, but from September we will start with a lot of courses. And first one will be Yuri Boychuk course in Turkey. This course will be in Turkish language for 3 days in Mersin area. We invite all Turkish growers to attend this course on a farm Duri Kanmantan. Then in a little bit more than a week, we will hold pathogen control as an investment course with Dmitry Medvedev in Poland. It's 1 day short course about how you can use your chemicals efficiently on your farm, not spending a lot of money on chemicals, and how to use effectively disinfection. Next course, also in September, will be actually 2 courses devoted to exotic mushrooms. We will look for 1 day to exotic mushroom business as for a business. And this part will be very interesting for those who, let's say, already growing button mushrooms, or just thinking about starting exotic mushroom growing farm. And second and third day will be about growing technology of exotic mushroom itself. And we do this course together with Kike, Chinese company that supply substrate of exotic mushrooms to European market also. In October, we have oyster mushroom growing course in Spain, in wonderful location in southern Spain. So in October, there will be amazing weather, and we will spend 3 days with Edward Lewandowski for oyster mushroom growing course. Later in October, we will have course with Wojtek Konieczny. This is slide here. We will have a course with Wojtek Konieczny in Poland for button mushroom growing course, and we also plan to have a button mushroom composting course in Poland late October with Wojtek Konieczny. In November, we have 3 days mushroom harvesting organization course with Lina Turowska, and this time we will do quite different programs, and the name of the course also will be a little bit different, because we will target supervisors on the mushroom farms, and we'll explain what is supervisor's role on a mushroom farm. Lina Turowska is our long-term partner and author of the book Mushroom Harvesting Strategy. Then our today speaker, Omar Haki, he will be leading course in India. It will be 5-day long course, 5 days, both composting and growing. In India, most of growers produce compost by themselves. So we decided to combine composting and growing in one course. we will hold it near the farm. So it will be, as usual, a combination of classwork and visiting farms. And introducing today speakers, Omar Haki, our expert with a huge experience in different countries in composting and growing button mushrooms. And you can visit a course that Omar will hold in India, and also he is available for online support and support on farm. If you need support, just let us know, and we will contact you with Omar and organize this support. And Makis Baksivanis, Makis is our most experienced expert with huge all life worked in a mushroom business, and Makis is very good expert in composting and mushroom growing. Makis knows everything, I would say, and today we are going to discuss okay, yeah, this was the last slide, and for today we are going to talk about equipment on mushroom compost yard. You know, the range of equipment, and on different countries in different areas, people use quite different setups of equipment. And we decided to speak about equipment that essential for mushroom compost yard, but we will not we will not discuss equipment that obviously you need to do composting. We will try to focus on those pieces of equipment that can be discussable if you need it or you don't need it. So feel free to ask question after we finish our short presentation, Omar and Makis, and ask, do I need this or I don't? And I hope our expert will give you all the answers. Now I give a word to Omar and Makis. Thank you. And I will show, I prepared some photos. So time to time I will show my screen if I find a proper photo to visualize what now is discussed. Thank you, Omar, please.
Thank you very much, Maxime. Thank you for the introduction. I welcome everybody to our presentation. As Maxime mentioned, this is a bit of an unusual one because there's two of us, and we're going to try and cover a lot of ground in the next few minutes. So what I'm going to try and do at the beginning is I'm going to try to list a very long list of the equipment, let's say the not so obvious equipment, as Maxime mentioned. And then I'll explain what I'll try very quickly also to explain what each of those pieces of equipment does. And then please feel free to note down any questions you have, and you can ask them at the end of the presentation after both myself and Makis finish. So I'm going to try and go quick because it's a pretty big list. Let's start with phase 0 and phase 0 or raw material preparation. So equipment number 1, straw and bale breakers destringers. This is a machine that removes the strings and breaks the bales as they come in. It's not always used by everybody, but for the big factories, it's one of the most practical machines to have because it makes the operation so much faster. The next one is the bale dunking bins or dipping tanks. So you have a sort of a mechanical method of dipping your bales, and this is usually a concrete or steel pool, and the bales are submerged, and of course it gives the option of getting all the water soaked into the bales very quickly and very rapidly to get the composting process started, or to do the dewaxing process, the beginning one. The next piece of equipment is the walking floor hoppers. Now, just to be clear, this isn't a mixing line. This is just a hopper, and the hopper is used to transport material onto a conveyor. So the walking floor hoppers are basically made of steel plates that work against each other, and they move the material slowly and they drop it onto a conveyor. Why is it important? Because it allows you to gradually feed material in a very uniform way. So it offers the option of uniformity, normally for big factories. Next up is the poultry and gypsum mixers. So this is a case when you are using chicken manure as a slurry, and the advantage is you get a very homogeneous mix and you apply it homogeneously. Not everybody uses it, but it prevents chicken manure dust from blowing away. It mitigates odors, so it has these advantages. It doesn't mean that you cannot or should not use dry chicken manure. You can do that just as successfully, but this is an option that bigger, let's say, factories sometimes use. The next one is goody water pit recirculation lagoons. Now, goody water is collected onto mushroom compost yards in lagoons. Do you recirculate or do you aerate? That's the big question. The answer is yes, if you can, and you should, especially if you are a small farm or a medium farm, because goody water turns anaerobic very, very quickly. So it is a huge advantage to have it aerated. Now, you might say some of the big farms or the big factories don't aerate. Well, the reason is in some of those cases, they quickly use or they quickly cycle their water, so it doesn't have a chance to go anaerobic. The next item on the list is the goody water aeration system. And I don't know, maybe Maxime can find us one of those videos. It shows a very clear example where you have the goody water having bubbles blown into it, and it aerates, it continuously aerates. Now that's a prime example right there, and it continuously aerates those tanks. There are more than one way to aerate the tanks. The best way is to inject water bubbles air bubbles into the goody tank, but you can also just recirculate the water, less effective. But anything that you do to improve the oxygenation of your goody water is definitely an advantage. And that because the goody water will supply those aerobic microflora into your compost, and that's one advantage that you always want. You don't want anaerobic bacteria starting out in your compost. Now we're going to talk about heavy-duty frontal loaders. So we're talking about big machines like Caterpillars and Volvos and JCBs, and they're usually equipped with large volume compost buckets. One thing to note, and I think Mekis will probably agree with me, whenever we go to a compost yard, we always advise to over-engineer the loader. Always use a bigger loader than your actual job. When you have a bigger loader than the job, you're less likely to have breakdowns. It's excellent advice. So always engineer the loader. It'll work at, let's say, 60 or 70% of its capacity, but it won't break down. If you have a loader that matches the job, it's more prone to breaking down. So that's one of the things. And we all know breakdowns are very costly in compost business. Now, the next item on the list is the special fork. So what do you use on your loader? Do you use a normal fork or do you use a normal bucket? The question is, it depends on the type of material you have. So you could use a fork if you're using normal wheat straw, but if you're using a fine material, then a fork doesn't really work. So if you're having to make compost with, let's say, very fine wheat straw or sugarcane bagasse, then a fork doesn't really work. So that really depends on the situation you're in. Next one up is the self-propelled compost turner. Now, the self-propelled compost turner, or the old classical type windrow turners, it's a big machine. It can have various sizes, and those of you who are familiar with it, it literally moves through a stack and creates a stack behind it and mixes, adds water, and mixes all the materials together. It also breaks the straw in many instances. So that's an old, excellent type of technology that really does a fantastic job of mixing. Moving on to the phase one process itself. So the phase one bunkers, or the forced aeration bunkers. And we all know, if you have an idea about bunkers are really just three walls with an aerated floor at the bottom, and air is forced through the floor into your compost. Why are bunkers important? Bunkers revolutionized compost making because they allowed us to shorten the time, they allowed us to have a better aerobic compost, and they reduced the emissions and they reduced the smell. The next item on the list is the indoor sealed phase 1 bunker, or I'm going to call it a tunnel. That is the same function as a bunker, but it's a completely enclosed system. Well, if we have time at the end, we're going to talk about the comparison between this system and the open bunkers. But for now, I'm just going to go through the list as quick as we can, and then we can see if we have enough time to discuss the differences. Next item on the list is the bunker aeration floors. So spigot floors. Spigot floors are concrete slabs. They're fitted with high pressure PVC pipes, and then you have these spigots that come out of these pipes and into the openings near the floor. Their job is to give high velocity, high pressure air evenly. So evenly is that's exactly what I was referring to right there. You can see the PVC pipes, you can see the high pressure pipes, and you can see the spigots actually sitting on top of them. And now the concrete will be poured to the level of the spigots openings. The idea behind an aerated floor is equal pressure. So an aerated floor is an equal high pressure system that pushes air into the compost as evenly as possible. The next item on the list is the fan for the spigot floor. So these are high pressure fans, normally delivering static pressure of 6,000 Pascal, but with low volume output. So low volume, high pressure. They are normally designed to give between 10 and 15 cubic meters of air per ton per hour. This is generally designed based on how much height you're going to fill in your bunker. So say you're going to fill 1,000 kilograms of material, then you design your fan accordingly. If you're going to fill 1,500, you design your fan according to that number. And the next item on the list is a top filling system. So a top filling system can work in a bunker and it can work in a tunnel. Top filling systems allow you to equally and very uniformly fill your bunker or your tunnel. Generally, these are used for big operations. There are two advantages. First of all, uniformity, and the second one is height. With this system, you can go very high in your bunker or your tunnel. You go up to 6 meters if you want to or if you need to. Generally, bunker fillers don't have that ability, and they'll probably end up filling maybe at 4.5 meters in some instances of high quality machines. The next item is the automation for phase 1 bunkers, and when we talk about automation, we are talking about the computer system that controls the phase 1 bunker or the phase 1 tunnel. You'll have to excuse me, but I'm having to go rather quickly through the list. I'm going to talk very quickly now about the phase 2 and phase 3 tunnels, and we all know these are enclosed rooms. These are enclosed airtight concrete, normally concrete chambers. Sometimes they're made with panels, and they have a protective coating on the inside to withstand chemical exposure, steam, etc. They're used to process your compost either as phase 2 or as phase 3. The next item on the list is the air handling unit for those tunnels. So you have and nowadays you have an air handling unit to do the job in the phase 2 tunnel or the phase 3 tunnel, where you have the ability to mix recirculated air with fresh air. In the old systems, you only had dampers and the fan would be separate. Normally nowadays it's just an air handling unit by itself. The next item is the tunnel circulation fans. So these are high static radial fans capable of circulating massive volumes of air up to 200 cubic meter per ton per hour, and that's for phase 2 and phase 3. Another item to mention or worth mentioning is steam boilers for the tunnels. Normally we avoid using steam for phase 2. We do use steam in extreme cases, but we do certainly use steam when we need to clean the tunnel. So when we need to eliminate pests and post crop, we will sterilize a tunnel at 70 degrees, especially for phase 3. Next item is chillers. So water cooling plants or chillers, these are associated with tunnels sometimes because you need to, especially in hot climate situations where you need to cool down the compost in preparation for spawning. And the next item will be the tunnel filling cassettes or the swivel conveyors that fill your tunnels. Some of these can be really big, up to 230 tons per hour. The advantage, of course, is uniform filling and filling in layers that don't allow the air to escape through channels. Next item is heavy-duty compost pulling tunnels. Now, when you have a pulling tunnel in your compost, normally this is associated with a grid floor. Tunnels made with spigot floors will normally not use pulling nets. You can just unload them with a loader. However, most tunnels with grid floors, they need a pulling net, and it's a cleaner and better and more efficient way of emptying your tunnel. With that, we go to the next item, which is the tunnel pulling winch. And the tunnel pulling winch is the machine, or the high torque machine, that pulls the entire compost on a net and then drops it onto a conveyor where it will be filled for either phase 2 or phase 3. Next item is the spawn applicator inoculation lines. These are just simple hoppers that allow you to add spawn. The same goes for the next item, which is the nutritional supplementing unit, which resembles in many instances spawn application. Spawn applicator hoppers. You have then other accessories such as tunnel cleaning machines. Tunnel cleaning machines are high pressure units designed to scrub, wash, and chemically disinfect pulling nets, especially pulling nets. It's important to remove all the organic residue from these nets. So now I'm going to talk about a few items that come after your tunnel. You have the spawning hall overpressure filter units, and you have the changing rooms, disinfection zones, respirators, spawn storage refrigerators, etc. And then of course, in some cases where you need to where you have strict environmental conditions, you have chemical scrubbing systems to remove ammonia, and you have a biofilter. Biofilters are just piles of piles of wood chips, where your final exhaust air from your indoor composting system blows through it, and it just removes all of the odors from that exhaust. And I'm quickly going to look at logistics now, very, very quickly. So in terms of logistics, you have another item called a compost block press, where the compost is actually pressed into blocks. There are some items such as CO2 evaporation coolers, vacuum coolers. These are all associated with cooling the compost in preparation for transport. Finally, I'm going to talk about a few things that we use for quality control. Very quickly, we have an item called the near infrared spectrometer, or NIRS. This is a very fancy piece of equipment that just analyzes your compost very quickly. It's excellent, it's quite expensive, but it has the ability to rapidly assess dry matter chemical profiling of your compost and your chicken manure. Another important item is the Drager tubes, where you measure ammonia. If you don't have a Drager tube, you can simply use litmus paper. Measuring ammonia at the end of phase 2 is very important. Finally, I'm going to quickly mention thermometers. You need thermometers for your compost yard. You cannot work without thermometers, and these are usually robust stainless steel tipped, and you need it to measure your compost temperature as well as your air temperature. Other items in your lab will include moisture meters, Kildal nitrogen meters, and pH meters. So as you can see, the list is quite expensive. Sometimes you have to know what to choose and what to leave behind. Some of these are really important for very big compost operations. Some of them, for smaller compost yard operations, you don't need the entire list, obviously. I apologize if I took a very long time to go through it. It's quite an extensive list. I'm going to turn it over to Chris at the moment, and he'll take you through a few items that he believes are worth discussing.
Thank you, Omar, for this comprehensive list of equipment. And we decided to start with this list to give you ideas about your future questions. Maybe something sound to you not needed, unfamiliar or something. So please write it down, remember, and ask question after we finish this presentation. And now Makis will start with few things that we use on a compost yard, and it can be doubtful if we definitely need them or we can skip them and buy something cheaper. Makis, please.
Thank you, Maxim. Thank you, Omar. Hello, everybody. Yes, we can start with woody water. Woody water is the most needed in mushroom farm. You cannot we cannot go on without this. We cannot finish quickly the composting, the straw on the beginning, and special with high pressure aeration system. Yeah, exactly, to make this bubble. Yes, exactly this photo. Because otherwise, if you don't have aeration, you have anaerobic. You don't need anaerobic. We can create a lot of troubles, a lot of problems, and of course we need all the water what drain around the compost yard from every phase of phase one, from compost, from piles, from even from bunkers, from everywhere it can go back to the goody water tank. And let's say small farms can fast circulate it, or with high pressure air system, but fast circulating is also good, is the most needed from all. If you don't have it, then you need more time to start the fermentation in the compost. Anyway, it's one of the things that you need. Then the second one is the loader, the front loader, and usually cost a lot of money, but the best is to use loader with forks to mix very well the compost. If the quantity is too small, yes, exactly, it's forks, yeah. Depends from the how big is the farm, and but it's more homogeneously the compost at the end. Yeah, the wheel loader is sometimes we say it's expensive, but at the end it's very cheap. Anyway, the next one is aeration bunkers, aeration
Makis,
floor.
can I ask you please about forks for loaders? So the alternative is to use cheaper and more standard buckets. And I saw many compost yards that takes compost with just buckets, standard buckets for frontal loaders. How different is usage of those buckets and forks? Do people need to buy expensive forks? And does this forks need this upper top? How to say?
Thing? Yeah. By just flat backs, you have some troubles with the compost. Is the compost come in some big patches together? Cannot mix very well. But at the end, the forks you can make by local somewhere. You can buy ready, but you can make a very small wheel loader with forks by local in every country, even in a very small farm. There's not any. It's nothing difficult. Yeah, and
okay, thank you.
Yeah. Okay, then we move to the aerated floor or to the bunker aerated floor. There are the bunkers. You have high pressure air, and is something that we need in small or big farm everywhere, except we use a compost turner like the very old. Yes, exactly. This is the bunkers. Easy to build. Very easy and very carefully. I have seen very small bunkers, like only 20 tons compost inside. I have seen large bunkers with hundreds of tons inside. Of course, we blow air, and the air is it's coming very hot from the middle of the compost. And yeah, exactly. Then we have high temperatures we try to reach with some techniques let's say, more or less fun, less air. Usually we have timers in the bunkers, and the timers say 5 minutes on, 10 minutes off. That depends from the stage of composting. On the beginning, we start very. We like to give oxygen in the compost and start the fermentation. Then slowly we reduce the on. That means less air in, less fresh air in, and we keep more closed everything. Then we have some temperatures like 75, 80 degrees. Yeah, some farms a little bit more. But I believe
Makis, tell us, please, is there a standard hole sizes for spigots and distance between spigots? From what depends those sizes of the holes and what should be pressure or how to build, let's say, a bunker if you're not using expert?
The standards many years ago was between the spigots 26 centimeter between each hole, yeah, and we usually we need pipes like 20 centimeter big. As long as possible, it's no problem. You can have bunker 50 meters, you can have bunker 10 meters. The pipes must be very carefully connected together because you have very high temperatures, and under the concrete, the pipes are moving. By temperatures of 75, 80 degrees, the pipes are moving. That means you must be very carefully when you build the bunkers and putting the pipes on the ground. Otherwise, the only thing you can read, the air pressure. You need high speed fans, and okay, the best is to regulate the speed of the fan. Let's say with inverter or something, because sometimes you need less, sometimes more. For winter time, you need a little bit less speed in the compost. Summertime a little bit more, and that's it's.
Okay, thank you very much. Thank you very much, Makis. Maybe we will ask some questions about this in the end. And now, Omar, please, you have also new parts of equipment to cover, which can be doubtful if we need it or we don't.
Yeah. So I'll thank you, Makis, for that, and thank you, Maxime. Very quickly, I have 3 items I'm going to mention. I'm going to show or try to demonstrate whether they're very essential or not. The first one is a discussion we have a lot: is do I go for a sealed phase 1 tunnel for the phase 1 process, or do I go for an open bunker? So phase 1 tunnels, just so that people understand some of the history behind them. They are largely due to environmental regulations in Europe. Europe demanded that the compost making industry go indoors. This was probably in the 80s or 90s. And so the industry had to make the compost indoors and then control the emissions that come out of those bunkers. And they used chemical scrubbers to remove ammonia, and they used biofilters to remove smell. So the process that was being carried out on platforms now turned indoors, and they started using them in tunnels. Now the alternative is a bunker, which is similar to a tunnel, but instead of a continuous fan and a closed, let's say, closed room, you have intermittent fan. What is the advantage of this or the other? Well, to be quite fair, if you don't have environmental restrictions where you are making compost, just use a bunker, build a bunker. It is much more economic, much cheaper, and the compost quality that comes out of a bunker with well-made compost is equal to, if not better than, a phase 1 tunnel. There's not a issue making the best compost in the world using a bunker. So that's the first item. The other items that might come up or that I'd like to mention, and I can show you how some of these are essential or not essential. Ozonators. So ozonators, it's a system where you produce ozone, and ozone is used for disinfecting surfaces. Again, it's there's a discussion going on whether this is important or not. To be fair, it's not really important because if you can do your disinfection in different ways or in more economic ways, items like ozonators are not important. The third and final item I'd like to talk about or mention is something called carbon dioxide evaporation coolers, or they use them for compost cooling. An expensive system for cooling compost that is being transported. So if you have spawned phase 2 or phase 3 and you're going long distances, say more than 12 to 15 hours, and you need to move that compost, you use a system of cooling. But if you don't have that, you can pre-cool your compost and make sure that during transport, the temperatures don't go over the 25 degree mark, and then you don't need that very expensive system. So you can see now from our discussion, you've seen items that can be very costly and very complicated. You don't need all of these to make good compost. Some of them are important, some of them you don't need them. Quickly also, I'm just going to talk about analytical tools. The near infrared spectrometer, it's a very expensive device, but if you have a simple compost lab, you don't need it. The thing that I would never make compost without, to be honest, is the Drager tube. For me, that's probably the most important thing. I use it to check ammonia before spawning. And if I don't have a Drager tube, I can just use litmus paper with some distilled water, and I can check if there's any residual ammonia in my compost on the day before spawning. Simple as that. I hope that we have covered as much as possible in this discussion. I know time doesn't allow, but it's a very big list. And I turn it back to you, Maxime, and hopefully if there's any questions from our guests.
Yeah, sorry, I missed last 3 minutes trying to reconnect to internet, but looks like I did. Okay, so now you can switch on your microphones and ask questions. Irfan, I see you have question, please.
Hi, Makis. Hi, Omar.
Hi.
I belong from Pakistan, and in summers, I am unable to down the compost temperature to 24 degrees for spawning. Can you please explain the cooling system in details?
Yeah. Yeah. The best cooling system is hydro panel. I think I suggest this sometime. Hydro panel. You make something like a room before your tunnels, inlet for the tunnels, and you cool down a little bit the air. It's easy to do, easy to fix it, and we can discuss later how to do this.
Okay, thank you.
But the main, of course, how you cool the compost is just evaporation cooling. So if you have dry weather, you can cool down your compost.
Yes,
quite good. But probably now it's very hot in Pakistan, is it?
he's out.
Irfan, okay. Yeah, but when it's plus 50, probably evaporated. Cooling, just evaporating water from the compost is not enough.
Yeah, in summers last year, I just did spawning at 29 at 30 and cool it down quickly in the rooms.
Yeah,
it's also possible, of course, to use cooling coils and kind of chillers if you can afford it. Also possible.
Okay, thank you.
Thank you. Any other questions? Please ask questions. I will ask meanwhile. What do you think about ammonia tubes and how should we measure? So, is it important to know your ammonia level during phase 2, or can go without this. Omar, let's.
Yeah, yeah. So,
Yeah.
so now there's 2 points where we normally like to measure ammonia at peak of pasteurization. So we know what is the highest level of ammonia, and then before spawning. I would say if I have to choose from one of these two, I would choose the one before spawning because that's more critical. The peak ammonia levels at pasteurization, they can be they have a very wide range number. But before spawning, I need my ammonia to be below 10 parts per million or 10 ppm, and that's the best way to measure it is using a Drager tube. Now, if I don't have a Drager tube, I can just use litmus paper. As we all know, ammonia is toxic to mushrooms and to agaricus, so it has to be clear before spawning. But so yeah, I would say just before spawning is the critical point.
Thank you. We have also a sorry. Yes.
Can I have a question, please?
Yes, Saleh, please.
Thank you very much. Thank you for the speakers and thank you for the organizing team. I have two questions, in fact. For a pasteurization tunnel designed to hold 35 tons of compost, can the air be distributed through a net of pipes, or it has to be in underground plenum? That's question one. Question two, what is the proportional between or ratio between the total area of the opening of the spigot and the total area of the opening of the centrifugal fan? Thank you very much.
Omar, can you please repeat the question?
So if I understood it correctly, his question is, can you use a spigot floor system in a closed tunnel, or does it have to be a plenum? That was the first question. So to answer that, I would say both are possible. The majority of people, the vast majority of people for phase 2, they use a plenum. They don't use spigot. However, as Maxime we were discussing not long ago, there are farms that do successful compost making for phase 2 and phase 3 using spigot tunnel floors. That does exist. The technology does exist, and the big companies, they build it as well. So that was the first question. The second question, I think, if I understood correctly, is he's looking for the relationship between the opening of the phase 1 bunker fan and the number of spigots in the floor. Is there a ratio between these two? If I understood his question correctly, I do not believe there is a specific ratio. The fan normally has a free inlet, a large inlet, and it's usually attached with the opening of the fan to the let's say the 20 centimeter network of pipes directly. You see a phase 1 fan for the bunkers. It's a static pressure fan. It works on pressure, not on air movement, not on high air movement. So it builds pressure like a balloon in your network of pipes underneath the compost or in the bunker. And that pressure allows the air to penetrate the compost. So usually keep a free opening for the bunker fan, don't restrict it. Generally, these bunker fans have openings on their side, and you can measure the air going into the fan using a simple device, and then you can calculate the volume of air that is being supplied into the bunker floor. I hope that helps answer the question.
Yes, thank you, Omar. Makis, can you add from your experience how good is compost produced on spigot floors, phase 1, and phase 2, phase 2 spigot floors in compared to phase 2 grid floors? Is there much difference, and what is better, let's say?
Okay, me? There are some difference. Of course, the grid floor is much better for phase 2 compost, but for small farms like until 150 tons compost per week, it's very expensive to build phase 2 tunnels with grid floor and pulling nets and empty winch and they are almost 4 or 5 times more expensive than spigot floors. And spigot floors working really very, very good There's more and more worldwide spigot floors around the world. Yeah. I don't see difference.
We recently discussed with one producer who uses spigot floors for phase 2, and he said that it's for him it works very well. And the biggest difference he sees from grid floors is more labor intensive work with spigot floor, more people, more movements, less automatization. But the results for him was okay. Okay, we have another questions in the chat. There is a question about temperatures in the compost. I'm sorry, I have to skip this question because it's outside the topic of today's webinar, but you always can message us, and Roman, our sales team, will arrange a short meeting with some of our experts, and you can get short answers to questions like this. Velocity is phase velocity at spigot in bunkers and tunnels. The question, what velocity of air should be in spigots of tunnels and bunkers? So Marcus, can you comment it? I think it's not about, so we don't measure velocity, we measure pressure in spigots.
The quantity.
Can you comment on it?
Yes, quantity of the air. You cannot say velocity because in all the spigots are the same velocity of air everywhere. Every hole have the same pressure of air, and we can work between. We start with 2,000-3,000 cubic per hour until 10,000 cubic air per hour. In a big farms, in a big bunkers, in a big compost yards.
Cubic meter per hour per ton of compost or per square meter?
Per ton of compost, yeah, per ton of compost, yes, per ton of compost.
Mm-hmm.
But
if I remember correctly, pressure in spigots usually more than 2,000 pp. I recently saw one farm who uses much less pressure, but when we did it, it was up to 7,000 not ppm, pascals pressure. Do you know the pressure in pascals?
I never use 7,000-8,000 except the pasteurization, but in bunkers is usually 2,000 to 4,000 Pascal. 2,000 to 4,000 Pascal. Yeah. 6,000-7,000 can reach sometimes in a tunnel during pasteurization.
Thank you. Next, it's more comment. Somebody, Aman, invite us on Cordyceps Military Smuggling Lab in India. Thank you. And we will visit India in November, and we will have course with Omar near Delhi. 5 days long course.
I will be glad to host you, please.
Is there a chance for one more question, please?
Yes, I will give you a word. One moment, Salah. But let me read the last one we have here. How much minimum time is required for the waxing? So yes, also the waxing, sorry, it's not in scope of today's webinar. We will not go to the technology. Omar now preparing new composting course. We already have one. Not bad, but will be even better. I hope soon. And we will cover all this in this course. And also come to our Omar course in India or Wojtek course in Poland for composting, and we will cover all those topics. Okay, we have another 10 minutes. Saleh, please ask your question.
Thank you very much. Okay, my question is about phase 2. For a 35 tunnel, for a 35 tons tunnel, is it possible to use a net of pipes and the spigots inside concrete instead of an underground plenum.
Would you like me to answer that, Maxime? Yeah, I'll just answer. Yes, the answer is yes. It is possible to use spigots instead of plenum. Yes, it is better to use plenum, but plenum, as Makis mentioned, it's a more expensive system, and it requires additional machinery like a tunnel winch and the net. But you can make compost in a closed tunnel with spigots instead of plenum. The answer is yes.
Thank you,
you
Omar.
very much.
Haris, you have a question?
Okay, Omar, talk about using pH paper.
Saleh, I'm sorry. Let's give other people to ask the question. Haris, please.
Fine.
Yeah, good evening to all.
Harris.
Yes, we hear you.
Yeah, I belong to Pakistan, but I'm working here in UAE. We are working since 4 years on exotic mushrooms and button mushrooms, but we import the compost all the way from Netherlands. Now we want to try making our own compost here in UAE, but when we did the calculation, so all the machineries, everything, it costs almost above 2 million euros. So it's very difficult to take the decision to invest for the start for the beginners, like almost 2 million, 2.5 million euros from the start. So what are the main equipments which we can do from the beginning, and later on when we are successful here, you know the very harsh climate of UAE. So if we are successful in this climate, then we can step next to the second stage, which will be like the commercial production of compost. The first will be the trial, and the second will be the commercial production. So can you suggest us some material from the list which we can purchase, and we start our trial from this?
I think Makis has a lot of experience in starting compost yards. Makis, can you start to comment on this?
Yes. I can start. Yeah. Depends on the quantity of the compost you like to do.
Okay.
How big is the quantity of the compost you like to prepare to make?
We have 2 growing rooms, and we need 20 tons for both, like 10 tons each.
10 tons compost, yeah. It's not so easy because the investment can be also for 100 tons, but what is more necessary is, first of all, a compost yard, small or big, doesn't matter. A small one, woody water tank, like where are you? In Pakistan? You are in Pakistan?
UAE, United Arab Emirates.
Huh? In?
Arab Emirates.
Yeah, a small woody water tank to circulate the water. A small forklift, a small loader with forks or without forks, doesn't matter. The quantity is very small, and 2 small bunkers and tunnel with spigots. That costs not so much. No, is not very expensive to build something like this. And later on, we can expand your compost yard, your farm. And the same, if you like, you can use for. You told me you have exotic. What kind of exotic mushrooms? He's out.
I don't know. Okay, Haris, you know our contacts. Please answer. Please ask.
No, we don't have voice.
Sorry. Let's, Haris, you can contact us privately, and we will answer. And let's finish this webinar with 2 questions from chat. What experience do you have with measuring the oxygen content? Oxygen content. Okay, it's a very good question. Straight for our topic, measuring oxygen during phase 1. Do we need it? How important it is? What it gives? Omar.
Yeah, it's a very good question. So you want to measure oxygen in phase 1 on a bunker, or you want to measure it in a phase 1 tunnel. In a phase 1 tunnel, it's much easier because the fan is continuously flowing. So you can take measurements, from the continuous flow, and then you can get a very accurate number. So normally you don't want to drop below 8% oxygen, content in the air. You don't want to go below 8. Below 8, you may create anaerobic problems. So very easy to measure in a phase 1 tunnel, closed tunnel. Not so easy to measure in a bunker. I've seen attempts, or I've seen systems where you have people trying to measure the oxygen in an open bunker, where they'd use different types of things, like they put a barrel on top of the compost and then they put the oxygen sensor. The problem with measuring oxygen in a bunker is it's not accurate, because the air isn't continuous, it's coming in puffs, in flows. So it won't give you a very good answer. You may get a very low oxygen measurement the minute the fan starts, because the compost has been sitting without a fan and it's on and off. But then the oxygen content improves as the fan moves. So not very accurate for bunkers, very accurate for phase 1 tunnels. What I would advise for bunkers, open bunkers, just work with volume of air and temperature. That's it. Work with your temperature so that you get your temperature to the 80 degrees as fast as possible, and then try to maintain it at 80 degrees.
Yeah.
I hope that that answers the question there.
Yes, thank you, Omar. I hope this answers the question. And the last question was, if you join us for training in India. Yes, Omar will lead this course in India in November. Omar will do both parts, composting and growing. Course will be 5 days. So please join us for this course. And in the finishing this webinar, I again want to say thank you to our partners, companies that support our activities, and of course to our experts today, to Marcus and Omar, and to all of you who join us for this webinar. Thank you very much. Keep in touch and join our following next webinars. Thank you very much.